Okay, so let's do in class 4, number 3. It says find the curvature of the ellipse at the point a, comma 0, and our ellipse here is x squared over a squared plus y squared over b squared equals 1, where a greater than 0, b greater than 0. Okay, so let's first recall the curvature formula. So here's our curvature formula here. Is the magnitude of capital T prime over magnitude of r prime. But notice here we're not given r, so we have to make r for this example. So let's make some observations. So first note that the ellipse up here can be written as x over a squared plus y over b squared equals 1. Okay, now I'm going to make a substitution. I'm going to let x over a equal say cosine of t and y over b equal sine of t. So let's do that. Okay, so again we have our x over a equal cosine of t and y over b equals sine of t. Now let's solve for x by multiplying both sides by a and solve for y by multiplying both sides by b. So we'll write down here. So solving for x, then multiplying both sides by a, we'll have x equals a cosine t, and we'll have y equals, multiplying both sides by b, b sine t. Okay, now we can write our r of t here. So we write it. So now my r of t will be my x, which is a cosine t I direction, plus y, which is b sine t j direction. So this parameterizes our ellipse up here, and where the t would go from 0 to 2 pi, you're going to go around the ellipse here. Okay, so again, 0 goes from 0 to 2 pi. So now we're trying to figure out which t value corresponds to a comma 0. So let's find that. Okay, so we need to find a t value that makes the point a comma 0. So that means that a would have to equal the a cosine t, and the 0 would have to equal b sine t. So I can divide both sides by a here. So doing that, we'll get cosine equals 1. So dividing both sides by a, you have then cosine is 1. Dividing both sides by b here, you have sine of t is 0. Okay. So we need to figure out what t value makes cosine 1 and sine 0 between 0 and 2 pi. Okay, well, it looks like it's going to be just at 0 because cosine of 0 is 1, sine of 0 is 0. So it follows t is 0. Okay, so t is 0. So basically looking for the curvature then up here when t is 0, something right here. So hence we need to find the curvature when t is 0. So it's going to be magnitude of capital T prime of 0 over magnitude of r prime of 0. So let's start finding these things. Let's first find our r prime. Let me write it to here. Okay, so r prime would be, well, the derivative of cosine, which would be minus sine. So it'd be minus a sine t I direction, derivative of sine, which would be cosine, so it's going to be b cosine j. Okay, now let's find the magnitude of this. Okay, so the magnitude would be negative a sine t squared plus b cosine t squared. Okay, let's simplify this a bit here. So we get distance to be a squared sine squared plus b squared cosine squared. Now I want to get rid of the sine squared, so I can use the identity sine squared equals 1 minus cosine squared. I'm going to write that here. Okay, so again I'm going to substitute 1 minus cosine squared in place of sine squared here. Okay, so doing that, let's see, let me write out what we get over here. So look at this, then it'll be a squared times 1 minus cosine squared plus b squared cosine squared. I can multiply the a squared in now, here, in here. Okay, so let's do that. So we get this then. Now, these last two terms have cosine squared here and here. I'm going to factor the cosine squared out on the right now. Let me do it over here. So I get this, I pull the cosine squared out. I wrote the b squared first. Okay, and lastly, I'm going to write this to the 1/2 power. Okay, so we get this then, writing it to 1/2. Okay, so let's summarize what we have. I'm going to erase a few things now. So let me erase a few things. Okay, so summarizing, we have our prime was negative a sine ti plus b cosine tj, and our magnitude of r prime was a squared plus b squared minus a squared cosine squared, all raised to 1/2. Now recall that our capital T, our unit tangent vector, is defined to be r prime over magnitude of r prime. So let's plug it in over here. So plugging in, we get this. The magnitude of r prime, 1 over it, would be this guy with a minus exponent. Okay, this 1 over. And then times our r prime here, so it'll be minus a sine tj plus b cosine tj. Okay, so again I have the negative exponent because it's 1 over the magnitude. Okay, let's keep going. Okay, I'm going to let f of t be this whole thing here. So let's multiply this f of t in then. Let's write it over here. Okay, so multiplying our f in, we'll have f times negative a sine t I, f times b cosine tj. Okay, so now I'm going to have to take derivative now. So the reason I want to take derivative is because recall we're looking for the curvature, and the curvature has a capital T prime on top, magnitude of it. That's why we're going to have to find derivative of our unit tangent vector here. So let's do that. Okay, so taking derivative, I'm going to have to use the product rule on this first one. So the f is my first function, the negative a sine is my second function. So the derivative of first function, so f prime times second, negative a sine of t, plus first f of t times derivative of second. The derivative of sine is cosine, so it's going to be minus a cosine t. That's going to be in the I direction, so that's the product rule. Then moving on to j portion here. Product rule also on this one. First function's f is going to be f prime times second function plus first function f times derivative now of cosine, which is minus sine, so it's going to be minus b sine t, all in the j direction. Okay, let's next find f prime. So my f's up here. So I'm going to have to use the chain rule on that. So let me write down here. Okay, so taking the derivative of my f up here, it's going to require the chain rule, so I'll take the negative 1/2, bring it in front, so I did here. Subtract 1 from the power, so it'll be negative 1/2 minus 1. Then multiply by derivative of the inside, so I have a cosine squared guy, so the 2 is going to come in front. It's like a chain rule, what's inside a chain rule. So the 2 will come in front here, so I have that part. Then multiply by derivative of cosine, which would be minus sine. So this would be the derivative of f prime using chain rule. Okay, and let's see, the 2 will cancel with the 2 over here. So let me rewrite it down below over here. Okay, simplifying a bit. So again, this 2 will cross off the 2 over here, and the minus signs will cancel. And I put the b squared a squared in front. And then negative 1/2 minus 1 is negative 3/2. So I'll have this as my answer for f prime. Now I want to evaluate at 0 now. So let's do that. So putting 0 in place of t everywhere, we'll get this. But now the sine of 0 is 0. And we got the sine of 0 right here, so it's going to make the whole thing 0. So the sine of 0 is 0, it's going to make the whole thing 0 because it's all multiplication. So we got 0 for f prime of 0. Let's next find f of 0. So recall our f of t was a squared plus b squared minus a squared cosine squared raised to the minus 1/2. So plugging 0 in place of t would have this, and the cosine of 0 is 1. So let's simplify this. So again, the cosine of 0 is 1, so this will just become a squared plus b squared minus a squared. A squared's cancel there, it's just going to be b squared to the minus 1/2. Let me write it here. We get this, and then multiplying those exponents, we'll get b to the minus 1 then. Okay? Okay, so we get b to the minus 1, which you can write as 1 over b. Okay, so let's summarize what we have so far. So let me erase a few things here. Okay, so summarizing, we need the curvature when t is 0. So we're looking for magnitude of capital T prime of 0 divided by magnitude of r prime of 0. We found f of 0 was 1 over b. We found f prime of 0 was 0. We found our magnitude of r prime. We found our capital T prime. So let's find capital T prime now at 0. So sticking 0 in place of t, we get... Okay, so sticking 0 in place of t everywhere up here, we'll get this. And now use the fact that the sine of 0 is 0 and the cosine of 0 is 1. Okay, so again, the sine of 0 is 0, cosine of 0 is 1. So making those substitutions, we get the following. We get this then, so it'll just be negative a f of 0, because that's the only guy that survives here in the I component. And in the j component, this is the only one that survives here. It's going to be b f prime of 0, j. But now f of 0 is 1 over b, f prime of 0 is 0, so let's note that here. Okay, so again, f of 0 is 1 over b, f prime of 0 is 0, that's gone. It's going to be a negative a over bi plus 0j. Now, again, we're looking for the curvature here. So the curvature requires the magnitude now of capital T prime of 0, so let's find that. So then the magnitude of capital T prime of 0 would be this guy squared plus 0 squared. So square root of this, so it's just going to end up being a over b. Okay, so we found this part of the curvature, this top part. We still have to find the magnitude of r prime of 0. My magnitude of r prime is right here, so let's evaluate this at 0 now. So plugging 0, we get this. So then the cosine of 0 is 1. So let's rewrite this now. Okay, so putting 1 in place of cosine, then it'll be a squared plus b squared minus a squared. The a squareds cancel. So it's going to be b squared raised to the minus 1/2, which is just b. Okay, so now we're ready to find the curvature because we have the top and the bottom part. So let's find it down here. So hence the curvature at 0, what's going to be magnitude of capital T prime of 0, which is a over b. So a over b divided by the magnitude of r prime of 0, which we found is b. Okay, and now this is division, so we can multiply by reciprocal. So let's do that. Okay, so our final answer then, so it's a over b times 1 over b, becomes then a over b squared. So this is our curvature here at t equals 0 on the parabola. Okay. So we're done with the question. So let's leave the video there. Okay.